Welcome, this is Amanda Rockinson-Zapke, and in this tutorial we're going to talk about choosing a specific statistical procedure. In the introduction tutorial, you'll remember we talked about factors for choosing a statistical method, and we really looked at the difference between choosing a parametric versus non-parametric procedure. Here we're going to get a little bit more specific, go a little bit deeper, and we're going to look at the decision-making process for choosing a specific statistical procedure. So let's get started. Now, if you remember back to the introduction tutorial, you'll remember that we talked about 3 factors for choosing a statistical method. We first talked about variables, and we talked about how you need to identify the type of variable and the level of measurement, because this helps you determine whether or not you're going to do a parametric or non-parametric analysis. Remember, if you have a dependent variable or variable of interest that's at the interval or ratio level, you choose a parametric analysis. If you have a variable that's at a dependent variable or variable of interest at the nominal level or ordinal level, you choose a non-parametric analysis. We also talked about assumption violation. Remember, with all data sets, you do assumption testing, and that there are certain assumptions that we make about the population, especially when we do parametric analyses. So if assumptions aren't violated, you choose a parametric procedure most of the time, as long as you've met the first criteria of levels of measurements. If the assumptions are violated and grossly violated, and you have a small sample size, then you may want to choose a non-parametric analysis. We also talked briefly about research design and how the purpose of the research design guides the researcher toward the hypothesis, or proposing a hypothesis of either association or a hypothesis of difference. We're now going to talk about each of these factors, as well as other factors, more in depth, and talk about how we choose a specific statistical procedure. Now here you see a list of questions for making a decision about which statistical procedure to use. Let's go over these briefly, and then we'll take a more in-depth look by walking through an example. The first question you need to ask about the hypothesis that you're proposing, or research question that you're proposing, is what are the variables under study? You then need to identify those variables, label those variables, such as label them independent, dependent, or variables of interest, and identify their scales of measurement, ratio, interval, ordinal, or nominal. Remember, you use a non-parametric test when you're working with variables of interest or dependent variables measured at the ordinal or nominal level, and you use a parametric analysis when you're working with variables of interest or dependent variables at the interval or ratio level. The next question that you need to ask is, does the research question or hypothesis imply a hypothesis of difference or hypothesis of association? Are you working with relationship or prediction, or are you working with difference? And this will determine whether or not you're going to do a test that looks at difference or a test that looks at relationship. The next question that you need to ask is related to a hypothesis of association. If the hypothesis is a hypothesis of association, then you need to ask the question about what type of relationship are you looking for? Are you looking for a relationship between variables? Are you looking for a predictive relationship between variables? Now, if you have a hypothesis of difference, you're going to ask a few other questions. The first question you're going to ask is, the data you're looking at, is it independent or is it dependent? Are you looking at the difference between 2 separate groups, or are you looking at the difference between the times in which the dependent measure was taken? For example, are you looking at pre-test versus post-test? You also want to look at how many groups or levels you have in your independent variable. Do you have 2 levels, such as, let's say, a control and treatment group, or do you have more than 2 levels? And the final thing that you want to ask if you have a hypothesis of difference is, how many dependent variables do you have? Do you have one dependent variable? Do you have multiple dependent variables? And if you have multiple dependent variables, are they related? And then finally, you're going to ask, what are the assumptions that are violated? So after you've collected the data, you're going to do assumption testing, and you're going to look at assumption violation. Now we're going to take a look at an example and walk through the decision-making process. Now, before we take these questions and walk through a specific example, let's take a moment and review different procedures that we can perform. Now, it's important to note here that this is a short list of procedures. There's probably thousands of different statistical procedures you can choose from, but these are some of the most common used with hypotheses of difference and hypotheses of association. Let's look at a few procedures that test hypotheses of difference first. First of all, we'll start with the most simple. We'll start with the dependent t-test. Remember that the dependent t-test is used when we want to know the difference between either a matched pair or if we want to know the difference between two scores in one group. For example, I may ask the question, do university students differ in their statistical knowledge before and after taking a statistics course? So here you'll see I have one independent variable with two levels and one dependent variable. And again, this is a within group analysis. So I have one group or one set of matched pairs. The second procedure is the independent t-test. Remember, the independent t-test helps us understand if a difference exists between two groups. For example, I may pose the question, do university students perform differently on their statistics final exam based on whether they take a statistics course online or residentially? I have two groups, the online group and the residential group. And I'm looking at one dependent variable, which is the score on their final exam. So for an independent t-test, you need one independent variable with two levels and one dependent variable. We then have the one-way ANOVA, which is very similar to the independent t-test. Here we look at the differences between three or more groups on one dependent variable. For example, I may expand the question to, do students differ in their statistics final exam score based on the type of course they participate in, whether it's online, residential, or blended? Here I have three different groups, online, residential, and blended. So for a one-way ANOVA, you need one independent variable with three or more levels or groups and one dependent variable. We then move on to the two-way ANOVA. Now the two-way ANOVA differs from the one-way ANOVA because we're actually looking at two groupings or two independent variables. And so we want to know, is there a difference between these two dependent variables and the groups within these two dependent variables, and also if there's independent variables. So we want to know if there's a difference between groups within these independent variables on the dependent variable, and then we also want to know if there's an interaction between these independent variables. So for example, we may say, do university students differ in their statistics final exam scores based on both the type of course they take, online or residential, as well as their gender, whether they're male or female? So for the two-way ANOVA, we need two independent variables that have at least two groups or two levels, and one dependent variable. We then have the repeated measures ANOVA. Now this is similar to the dependent t-test. Here we're working again with one group of individuals, and we're measuring them multiple times, at least three or more times. Or we're working with matched pairs or a group that we want to measure on three different let's say three different scores. But the repeated measures ANOVA, an example of this, let's go back to the one we were using for the dependent t-test, or one that's similar. What we might say is do university students increase in their statistical knowledge before, during, and after taking a educational statistics course? So here we've measured 3 times statistical knowledge. We measure before, during, and after a course. The final procedure I want to talk about that tests hypotheses of difference is the MANOVA. Now with the MANOVA, you have one independent variable. You're looking at the difference between groups, either 2 groups or 3 groups, or 4 groups, however many groups you have. So the difference between groups on a linear combination of related variables. So you're looking at the difference between groups on several dependent variables that are related. So for example, let's say that we don't want to just know about students' statistical knowledge based on the final exam, but we also want to know their perception of knowledge or their perception of learning. And we know in the literature these 2 variables are related. So we might ask the question, do university students differ in their statistical knowledge based on their final exam score and their perceived learning based on what type of course they're enrolled in? So here we see that we have 2, and we're going to deal with 2 groups again. We have 2 groups, the online versus the residential, and we want to know if they differ both in their statistical knowledge based on their final exam and their perceived knowledge. And again, these are 2 related dependent variables. So here with the MANOVA, you need one independent variable with 2 or more levels and 2 or more related dependent variables. Now let's take a look at a list of procedures used to test the hypotheses of association. Again, this is not an exhaustive list, but these are probably the most common bivariate and multivariate analyses used to test hypotheses of association. The simplest is probably the bivariate correlation, Pearson's R, Spearman Rho. Here the researcher wants to know the relationship between 2 variables. So he or she may ask, is there a relationship between university students' sense of community and their course points? Here for a bivariate correlation, you see we need 2 variables of interest. And here we have course points and sense of community. Then there's the partial correlation. In the partial correlation, the researcher is interested in knowing the relationship between 2 variables while controlling for or adjusting for a 3rd, 4th, or 5th variable. For example, the researcher may ask, is there a relationship between students' course points and their sense of community while controlling for their level of confidence with the course material? Here you see we have 2 variables of interest. So a partial correlation needs 2 variables of interest and 1 control variable. And here we saw we have the 2 variables of interest are course points and sense of community, and the control variable is level of confidence. The next analysis is the bivariate linear regression. The aim here is to determine if one predictor variable can predict a criterion variable. So the researcher may ask the question, can university students' sense of community predict their course points? We then move on to multivariate. First of all, we have a multivariate linear regression. Now there are different types of multivariate linear regressions, and how you ask the question and the overall aim determines the type. However, we're just going to talk in general about multivariate linear regressions here. The multivariate linear regression is used when the researcher wants to know if multiple predictor variables can predict one criterion variable. So here, let's say our sense of community has 2 separate scales, learning and connectedness. And here the researcher may want to know, can learning and sense of connectedness predict the course points for university students? So we have 2, here you can see what's needed for a multiple regression is 2 or more predictor variables and 1 criterion variable. And we have 2 predictor variables, learning community and connectedness, and 1 criterion variable, which is course points. That finally brings me to the canonical correlation. The canonical correlation is used when a researcher wants to know the relationship between 2 sets of variables. Let's say here the researcher wants to know, is there a relationship between the 2 subscales of sense of community, learning community and connectedness, and not only course points but also perceived learning? So is there a relationship between connectedness and learning community and course points and perceived learning? So here you can see for a canonical correlation you need 2 sets of variables. So now we've gone over the potential statistical procedures that we can choose from. Let's go ahead and take a look at an example. Let's walk through the list of questions for the decision-making process. For this question and corresponding hypothesis, the question that we're going to look at is there a difference in college students' course points based on whether or not they participate in an online statistics course as opposed to the residential statistics course? And the corresponding hypothesis is something we're going to formulate in a minute once we determine our variables. So the first question we ask in the decision-making process is this: what are the variables under study? We need to label them, and then we need to identify them as independent, dependent variables, variables of interest, and we need to identify their scales of measurement or their levels of measurement: ratio, interval, ordinal, nominal. So let's take a look at the question. Remember, the question is there a difference in college students' course points based on whether they participate in an online statistics course as opposed to a residential statistics course? Now I encourage you to go ahead and pause this tutorial and identify the variables, label them, and identify their scales of measurement. Here we see that the researcher wants to know the influence of one variable on another variable. So we have independent and dependent variables here. First of all, the independent variable, the variable that the researcher is either manipulating or looking to have an effect on the dependent variable, is type of statistics course. And here we see there's two levels, and that's residential and online. And since this has two categories that can't be ranked, ordered, or measured, then we can identify it at the nominal level of measurement. Next, we have the dependent variable. What is the researcher here looking to affect? Well, course points. And course points are measured from 0 to 1,000, so there's categories, the different points, 1, 2, 3, 4, 5. They can be rank ordered, and they can be measured, and there's an absolute 0. Somebody can have a 0 number of course points. So this is measured at the ratio level. Now, if we remember back to the hypothesis tutorial, we remember if we have one independent variable and one dependent variable, we only need one null hypothesis to test. So the null hypothesis here is that there is no statistically significant difference in college students' course points based on whether they participate in either an online statistics course or a residential statistics course. So we've answered the first question. We're going to move on to the second question in a moment, but let's talk a little bit about what the answers to this question or these questions tell us. So at this point, we know that our dependent variable is measured at the ratio level. Therefore, it's appropriate to do a parametric analysis or procedure. So we can rule out non-parametric procedures at this point and look at the parametric procedures. Now, we just went over a number of parametric procedures that are commonly used for analysis purposes. But here's the list of parametric procedures that we can potentially choose from. You'll also see a list of non-parametric listed here, and again, at this point we can rule those out. So let's move on to the second question in our decision-making process. The second question or questions are these. Does the research question imply a correlation, a prediction, or a test of difference? And therefore, are we using a hypothesis of association or a hypothesis of difference? I encourage you again, pause the tutorial and make a decision. Answer these questions. Well, here we see the question asks, is there a difference between two groups? The word difference implies that we're looking at a difference test and therefore a hypothesis of difference. Since we've determined that we are testing a hypothesis of difference, we can rule out procedures associated with testing hypotheses of relationship or association. So we can rule those out, and so now we know we're looking at procedures which test the difference. So here's a list of procedures that test hypotheses of difference. You can see we could potentially be doing a dependent t-test, an independent t-test, some type of ANOVA or MANOVA. So now in our decision-making process, we can move on and focus on the questions that look at hypothesis of difference. So the first question we're going to ask is our data, is it independent? Are we looking at two separate groups? Or are we looking at a dependent group or matched pairs? Are we looking at one group with two scores or matched pairs each with a score? Another way to ask this is the design concerned with within group, or is it concerned with between group comparison? And also related to that, if we determine that we have two separate groups, or we have dependent groups, what we need to decide then is how many levels does this basically independent variable have, or how many categories or groups are we dealing with here? So that's related to the independent variable. We then also need to ask the question, how many dependent variables do we have? And here we've already identified the independent variable and dependent variable, so we can ask these questions specifically related to this independent variable and dependent variable. So in types of statistics course, are we looking at two independent groups? Are we looking at a dependent group? And how many groups or levels does this independent variable have? And then finally, with our dependent variable, this is a pretty easy question. How many dependent variables do we have listed here? Again, I encourage you, pause the tutorial, answer these questions, and then move on. Well, let's start with the independent variable. First of all, for the independent variable, are we dealing with two groups that are independent of one another? That means that each groups are separate, or are we dealing with dependent groups, or a dependent group, one group, or within group? Well, here we see that we have two separate groups, residential and online. So we're dealing with independent data. The second question that we asked about the independent variable here was, how many groups do we have? Well, we have two groups, residential and online. The next question we asked was about the dependent variable. How many dependent variables do we have? Well, we have one listed here, course points, so the answer to this question is 1. Now the final question we're going to ask in our decision-making process is, what assumptions are violated? Now, ideally what you need to do is collect your data, identify your analysis, and run your assumptions related to that analysis or related to that procedure, and then answer this question. However, we know that most analyses require that the assumption of normality be met. We also know that many of our independent, or actually all of our independent procedures that test difference need to meet the assumption of homogeneity of variance. Now, let's assume in this case that our assumptions have been met. They're not violated. Our data is normal. We can assume equal variance. And therefore, what that tells us is that we can move on with a parametric analysis. Because again, remember, we have a dependent variable that's measured at the ratio level. If our assumptions are not violated, we can then perform a parametric analysis. If our assumptions are grossly violated, we may want to consider a non-parametric alternative. And remember, we looked at those a little bit earlier. So now that we've answered all the questions, we've collected everything we need to make a decision about the procedure that we need to perform to analyze the data. Remember, we've determined that we're testing a hypothesis of difference, therefore we're going to do a test of difference. So we're just going to look at a table or a chart that shows us the test of difference because we ruled out tests of association. Now I will say this chart here comes from the statistics guide, which is available with the tutorial. So this is from the statistics guide. Now let's use the answers to our questions to make a decision about which test of difference we're going to use. First of all, we need to take the information about our independent variable and its level of measurement. remember we had one independent variable. So that means we rule out this bottom choice here. So we have one independent variable. And remember that our independent variable had two groups, online versus residential. So we can go ahead and say, choose the first category here, or the first row here. Next, we need to take our information about the dependent variable and determine what we have here. Remember, we had one dependent variable and it was measured at the ratio level. So all of these choices listed here are appropriate, but we're going to continue down the row that corresponds with our information about the independent variable. So we have one nominal independent variable with two levels, one dependent variable that was measured at ratio level. The next question relates back to the independent variable. Remember, we looked at, was our data independent or dependent, and we determined that it was independent, and we also determined that we just had two groups. So here again, since we have two independent groups, we're going to continue down the row that we have been, which is the very top one, and we see the significance test that we need to perform then is an independent samples t-test. Now, this makes sense. Think about the different procedures that we reviewed toward the beginning of this tutorial. Remember, we looked at what you need for different procedures and what their purpose is. Remember, the purpose of an independent samples t-test is to test the difference between two groups on one measure. And remember, in our question, we asked the question, is there a difference in college students' course points based on whether they participated in an online statistics class as opposed to a residential class? So we are asking about the difference between two groups, one independent variable, on one dependent variable. And for an independent samples t-test, we need one independent variable with two groups, no more than two groups, and one dependent variable. Now let's say for a moment, so we've determined that, but let's say for a moment we change that question and we say that we have three groups. So we're looking at the difference between residential, online, and blended, and we're looking at how those three categories or those three treatments affect our dependent variable of course points. What we see then is that this changes our significance test. And the only thing really that it changes is our information about the independent variable. We're now looking at one independent variable with three or more groups. So what you'll see is we'll need to, our independent samples t-test isn't going to work in this chart. If we move down 1, 2, 3, 4 rows here and move across the column, what we'll see is that we have one nominal variable with three or more groups. We have one dependent variable. Our groups are still independent of one another, so our appropriate analysis would be a one-way repeated measures ANOVA. Now, just to make sure we completely understand or have a good grasp of this decision-making process, we're going to briefly look at a few more examples. So let's go ahead and look at another example. Now this time, instead of walking through this process in depth, we're going to take a look at the scenario and then we're going to walk through the questions on this slide. So my recommendation to you for this scenario, as well as the ones coming up, is that you go ahead, read the scenario, pause the tutorial, answer the questions, and then come back and discuss them with me. So let's take a look at this scenario. Every semester, a professor gives his students a pre-test and a post-test to determine if they improve in their understanding of course concepts. Thus, the researcher asks this question: is there a difference in the number of course points earned on their educational statistics pre-test and their post-test? So first of all, we need to identify the variables, label them, and identify their levels or scales of measurement. So here we see that we have two different variables, and we're going to identify them as independent and dependent because we're looking at the difference and we're looking at how something affects something else, or one thing affects something else. So let's start with our independent variable. Our independent variable is actually time, the time of the pretest and the time of the post-test. And this is a nominal level measurement because we're looking at two different categories. Next we have, and we can't really rank order them, we just have before and after. And we can't say one is better than the other in any way, so they're nominal. Next we have the dependent variable, and here we see the dependent variable is the number of course points earned. Since it's number of course points, they can be measured, and we can say that there's 0 course points, so we're looking at this dependent variable being measured at the ratio level of measurement. So since we have a dependent variable at the ratio level of measurement, remember we can then assume that we're going to continue with a parametric analysis. And we're going to come back to this information we just identified in a moment to further answer other questions. But the next question we have is does the research question imply relationship, prediction, or difference? Well, again, here we can see that the question is there a difference? This implies we're looking at difference, and therefore we have a hypothesis of difference. And our hypothesis of difference here would be, again, because we have one independent and one dependent variable, we need one hypothesis, so it would be there will be a statistically significant difference in the number of course points that students earn on their educational statistics pre-test and post-test. So we don't have to answer questions about hypotheses of association, so we move on to hypotheses of difference, and we know that we're going to do a test of difference now. So if we have a hypothesis of difference, the next question we ask is our data independent? Do we have two separate groups, or do we have dependent data? Well, let's think about this. We have one group of students, and we're going to take a measurement at their pretest and a measurement at their post-test. These groups aren't separate, so they're dependent upon one another. So we're going to be doing a within group analysis. The next question is how many groups do we have? Or in this case, the better question would probably be how many levels does our independent variable have? Well, we just said we have time 1 and time 2, a pretest, a post-test, so it has 2 levels. The next question we need to ask is how many dependent variables do we have? We've already determined we have one dependent variable, the number of course points. The final question we'd ask are there any assumption violations? And let's assume in this case, no. So, in this scenario, the researcher wants to know if there's a difference in one dependent variable based on 2 different times. He's using dependent data, or the group is dependent on each other. So since the researcher wants to know this, is there a difference between course points earned by students from pre-test to post-test? I want you to think about what would be the best analysis. Now, since we're looking at dependent groups, that really narrows our choices to 2 different analyses that we've gone over in the tutorials and in this tutorial specifically, and that is the dependent t-test and the repeated measures ANOVA. And since we don't have 3 levels of our independent variable, we only have 2 levels, probably the best choice in this scenario would be a dependent t-test. So we went through our decision-making chart in the statistics guide, we took all this information, we'd probably come up with, or hopefully come up with, the dependent t-test. Let's take a look at another case. So here we see the professor is thinking about requiring a remedial statistics course for his students who don't do well on the pretest. However, he's not sure if it would be helpful. Thus, he's interested if prior statistical knowledge assists students in their performance on their final exam. So, he poses this question: what is the relationship between pretest scores and final exam scores after controlling for cumulative GPA in previous statistics courses? Now, he wants to know the relationship between the pretest and the final exam also without the influence of the GPA. So let's walk through this scenario. Now, again, I encourage you go ahead and pause the tutorial, walk through these questions, and then come back and discuss them with me. Our first question here is, what are the variables under study? And we're going to label them, and we're going to identify their scales of measurement. Here we see that the researcher's simply interested in the relationship between two variables. He's not looking to see if one variable necessarily impacts the other variable or has an effect on the other variable. So he has variables of interest here, and he actually has 3 variables of interest: the statistics pretest scores, the final exam scores, and the GPA. So we just identified there are 3 different variables. And we're going to say that, and we know that all these variables, scores, GPA, they can be measured, they can be rank ordered, they can be put into categories. And let's say that they all have a 0. People could have a 0 for a GPA, a 0 on a final exam, a 0 on a pretest, so we can say they're measured at the ratio level. Our next question then becomes this: does the researcher imply a correlation, prediction, or difference test? So are we dealing with a hypothesis of association or a hypothesis of difference? Well, we just said that the researcher doesn't necessarily want to know how one variable affects another. He just wants to know about the relationship between variables. Therefore, we're dealing with a hypothesis of association. So based on these 2 questions, what we can say is because we're looking at variables measured at the ratio level, we can say we're going to probably continue with a parametric analysis. And since we have a hypothesis of association, we can then continue or just looking at tests of association or tests of relationship. Now, let me take a moment here and talk about hypothesis, because we forgot to write our hypothesis. Our hypotheses, or actually we would have hypotheses because we're dealing really with 3 variables. So the first hypothesis would just deal with the relationship between the 2 variables. There will be no statistically significant difference between the pretest scores and the post-test scores. So that's the first thing we're interested in, that 0 order correlation. And then we are also interested in testing the hypothesis that there will be no statistically significant difference between the pretest scores and the final exam scores after controlling for or adjusting for the cumulative GPA in previous statistics courses. So those are our 2 hypotheses, and again, we're looking at relationship. So we then move on and ask the next question related to hypotheses of association, and there's just one. And it's this question: is the focus... Actually, there's 2. I apologize. There's 2. First of all, is the focus of the hypothesis of association, is it on relationship or predictive relationship? Well, we're not asking does one variable predict another, so it's just simply on relationship. The next question we're going to look at is how many variables are we looking at here? And what types of relationships are we looking at between them? Are we looking at a relationship between one-to-one variable? And in the first hypothesis we are, but we're going to even take it a step further. We're looking at the relationship between one-to-one variable while controlling for another. We're not looking at the relationship between many-to-one variables. We're not looking at how many variables predict another variable. We're not looking at sets. How do 2 different sets of variables relate? We're looking at the relationship between one variable to one variable, and we're controlling for or adjusting for another variable. So then that brings us to the final question. And the final question is, do we have any violations in our assumption? And we're going to assume no here. So we can take a moment and look at our chart and look at specifically the tests for association, and which test tests the relationship between variables while controlling for another variable. If you said a partial correlation, you're correct. So probably the best statistical procedure to choose here would be a partial correlation. Okay, let's look at one more example. Here's this example. The same professor wants to examine if there's a difference in course points based not only on the delivery system used or the environment, the online versus residential, but also race. if he finds a difference, he could realize or determine if he needs to evaluate his own course ethnic sensitivity. He may realize based on these results that he's more effective as a teacher in one environment and better at adapting his teaching methods to be ethnically sensitive in one environment over another. So he then poses this question: do students differ in terms of their course points based on their race and the delivery environment? Again, I encourage you at this point, pause this tutorial, walk through the questions, and then come back and discuss them with me. So the first question we're going to look at here is, what are the variables under study? We're going to label them, and then we're going to identify their skills or levels of measurement. So here we see that the researcher wants to know if two different factors influence another factor. So the two factors that the researcher wants to look at that affect another factor are race and delivery system. So we can say that race and delivery system are our independent variables. Now, race is category: Caucasian, African American, Hispanic. They can't be ranked, they can only be put into categories, therefore race is nominal. We can say the same about delivery system: online versus residential. There are two categories that can't be ranked ordered, so this variable is also measured at the nominal level. We're looking then to influence one variable here, and have you determined what that was? Course points. Since course points can be put into categories, numbers can be put into categories, they can be rank ordered, 2 is higher than 1, and they can be measured, and there's an absolute 0. You can have 0 course points. We can say course points is measured at the ratio level. Okay, so we've determined we have 2 independent variables and 1 dependent variable. The next question then we're going to, and we determine that dependent variable, before we move on to the next question, we determine that the dependent variable is measured at the ratio level. Therefore, we can make the determination that we'll probably continue with a parametric analysis as long as all our assumptions are not violated. So then when that brings us to the next question. The question we're asking here, are we looking for a difference, or are we looking for a relationship? Are we going to test a hypothesis of difference or a hypothesis of association? Well, based on the fact that we have 2 independent variables and 1 dependent variable, thinking back to our hypothesis tutorial, that means we have 3 null hypotheses, and this is what they are. Students will not statistically significantly differ in their course points based on their race. Students will not statistically significantly differ based on the delivery environment. And then finally, students will not statistically significantly differ in course points, I missed that word, in course points based on both the race and the delivery system. So in each one of those hypotheses, what word did you hear? Did you hear differ? Therefore, we're dealing with hypotheses of difference. So we move on then to the next question that focuses on the hypotheses of difference. And since we're, again, using hypotheses of difference, we are going to do a test of difference. Our next questions then are, is our data independent or is it dependent? So look back to that independent variable. Independent variables, race and delivery system. Are we looking at separate groups? Are the delivery system groups, are they separate, first of all? Yes, because students are enrolled in either an online or residential. They're not enrolled in both. We're not measuring them in both. We're measuring them in one or the other, so that's a separate group. We then need to look at our other independent variable, and that's race. Here again, we're going to have categories of race, and students are going to fit into one. So maybe we have Caucasian, African American, Hispanic, biracial. So those are separate groups. So our data is separate. We're then going to ask the question, we're going to look at each independent variable and say, okay, how many groups or how many levels do we have? Well, with race, we have multiple levels. I just mentioned, I think, 4 or 5. So we have 4 or 5 different levels. With delivery system, we have 2. Online versus residential. We now then move on to looking at our dependent variable. or variables, and we ask how many dependent variables do we have? Well, we've already established that we have one dependent variable, and that's points. The final question then is, do we have any violations in our assumptions? And at this point we're going to say no. So here, based on the information we have, we've determined we have two nominal independent variables. Two nominal independent variables. One has multiple groups, one has two groups. Okay, so we would look at our table in our statistics guide and we would say, okay, we'd move down the row and we'd say, okay, we're looking for a analysis that we can analyze two independent variables. Next, we're going to look at the dependent variable. We have one dependent variable. One dependent variable. So we're going to look next down that row. What analysis can analyze two independent variables and one dependent variable? And remember that dependent variable is measured at the ratio level. And we know both of our groups then are independent of one another. That we're not looking at dependent data, we're looking at independent data. So what analysis can be used for the purpose of simultaneously evaluating the effect of two independent variables on one dependent variable? If you said a two-way ANOVA, you're correct. So in this scenario, we'd use a two-way ANOVA. Now I'm going to throw one little monkey wrench in there. What if we go back to that dependent variable question and we say, well, we don't have just one dependent variable. The researcher decides he doesn't want to just look at course points. He also wants to, let's say, look at perceived learning. So we have two related dependent variables. How does that change our analysis, or what analysis would we use? So we have two independent variables and two related dependent variables now. Looking at that table, what do we use? If you said a two-way MANOVA or a MANOVA, you're correct. So now you have the tools to make a decision about a statistical procedure. So this concludes this tutorial. Like I said, at this point, you not only know the factors you need to consider for choosing a statistical method, but you also know the process of making a decision and choosing a specific statistical procedure to analyze your data.